Hello everyone, welcome to my channel Learn with Nisha ji. We are studying class 9 science chapter 4 and here we are on the topic 4.2 that is structure of an atom. बहुत important topic है, right? If you have not subscribed the channel yet, you can subscribe the channel Learn with Nisha ji. And if you want one-to-one sessions, okay, so you can fill up this form. I'm sharing this link in the description section, right? So let's begin with the topic. So स्ट्रक्चर ऑफ एन एटम, ठीक है. इन चैप्टर 3 हमने देखो डाल्टन्स एटॉमिक थ्योरी पढ़ी थी, राइट. इट सजेस्टेड दैट एटम वाज इंडिविजिबल एंड इंडिस्ट्रक्टिबल, राइट. बट दो फंडामेंटल पार्टिकल्स की डिस्कवरी हुई, इलेक्ट्रॉन्स एंड प्रोटॉन्स इनसाइड द एटम. So Dalton's atomic theory was failed by this. Okay, it was then considered necessary to know how electrons and protons are arranged in an atom. Okay. To explain this, many scientists have proposed atomic models. Okay. तो पहला जो मॉडल आया था वो जे थॉमसन ने हमें दिया था. ठीक है. मॉडल फॉर द स्ट्रक्चर ऑफ एन एटम. लेट्स स्टडी दैट. So here comes the Thomson's model of an atom. Very important. ये एग्जाम में आता है. जैसे आपको डायरेक्टली दे देंगे like you have to explain and draw the Thomson's model of an atom, right? तो पहले हम थोड़ा जे थॉमसन के बारे में पढ़ते हैं. Like he was there from 1856 to 1940. He was a British physicist and was born in Cheetham Hill, a suburb of Manchester on 18 December 1856. He was awarded Nobel Prize in Physics in 1906 for his work on the discovery of electrons. तो ये इनका एक major work था. Okay. He directed the Cavendish Laboratory at Cambridge for 35 years and 7 of his research assistants, they subsequently won the Nobel Prizes. Right? So very good work they did. So now let's see the model. Thomson proposed the model of an atom to be similar to that of a Christmas pudding. Okay. Electrons in a sphere of positive charge were like currants, okay, dry fruits in a spherical Christmas pudding. तो आप डायग्राम के थ्रू देख सकते हो. जैसे ये सपोज आपका पॉजिटिवली चार्ज स्फेयर है, ठीक है, और ये आपके इलेक्ट्रॉन्स हैं जो नेगेटिव साइन और सर्कल से डिनोट किए हैं, राइट. नाउ we can also think of a watermelon. The positive charge in the atom is spread all over. Like the red edible part होता है जो watermelon में, और electrons are the studded parts in the positively charged sphere like seeds in the wetter watermelon. ठीक है, तो इस तरह से इन्होंने ये मॉडल दिया था, right? So Thomson proposed that first is an atom consists of a positively charged sphere and the electrons are embedded in it. Okay. Second is the negative and positive charges are equal in magnitude. So the atom as a whole is electrically neutral. Right? तो थॉमसन्स मॉडल ने बहुत इंपॉर्टेंट ये चीज एक्सप्लेन की कि एटम्स आर इलेक्ट्रिकली न्यूट्रल. ओके. Results of the experiments carried out by other scientists could not be explained by this model. ठीक है. हुआ क्या, ये मॉडल तो काफी अच्छा था और इसमें कई चीजें एक्सप्लेन हो रही थी, बट स्टिल आगे कुछ एक्सपेरिमेंट्स किए गए जो कि इस मॉडल के थ्रू मींस मैच नहीं हो रहे थे. सो लेट्स सी दैट आल्सो नाउ, राइट. So the second one is the Rutherford's model of an atom. Okay, so Ernst Rutherford was interested in knowing how the electrons are arranged within an atom. ठीक है, कि उनका exact arrangement कैसा है. So he designed an experiment for this. ठीक है, experiment में क्या किया, fast moving alpha particles were made to fall on a thin gold foil. ठीक है, तो आप इधर देख सकते हो, दिस इज गोल्ड फॉयल स्ट्रक्चर. यहाँ से अल्फा पार्टिकल्स, फास्ट मूविंग अल्फा पार्टिकल्स आर मेड टू फॉल ऑन इट. ओके, तो ये गोल्ड एटम्स हैं बेसिकली जो सर्कल्स में शोन है, राइट. सो ही सिलेक्टेड अ गोल्ड फॉयल बिकॉज ही वांटेड as thin a layer as possible. ठीक है, तो गोल्ड फॉयल was about 1000 atoms thick only, right. अल्फा पार्टिकल्स क्या होते हैं, दे आर डबली चार्ज्ड हीलियम आयंस. ठीक है, since they have a mass of 4 units, the fast moving alpha particles have a considerable amount of energy. ठीक है, and it was expected that alpha particles would be deflected by the subatomic particles in the gold atoms, right. Since alpha particles were much heavier than the protons, he did not expect to see large deflections. Okay. बट जो रिजल्ट्स थे दे वर टोटली अनएक्सपेक्टेड रिजल्ट्स. तो क्या क्या रिजल्ट्स दिखे इसमें? मोस्ट ऑफ द फास्ट मूविंग अल्फा पार्टिकल्स पास्ड स्ट्रेट थ्रू द गोल्ड फॉइल. ठीक है, जैसे आप देख सकते हो, दिस इज पासिंग स्ट्रेट, दिस इज पासिंग स्ट्रेट, दिस लाइक, ओके. Some of the alpha particles were deflected by the foil by small angles. जैसे ये यहाँ पे आया और small angle से deflect हो गया, right? Surprisingly, 1 out of every 12,000 particles appeared to rebound. Okay, जैसे ये यहाँ से गया particle और ये वापस आ गया, ठीक है? तो 1 in 12,000, very few, right? So this diagram very beautifully shows the scattering of alpha particles by a gold foil. Very important diagram, right? So, as per Rutherford, this result was almost as incredible as if you fire a 15-inch shell at a piece of a tissue paper and it comes back and hits you. ठीक है, ऐसा कुछ result था ये. So, this was the experiment done by Rutherford, right? So let's see, like Rutherford, he was born in 1871 and he was there till 1937. He was born at Spring Grove on 30th August 1871. He was known as the father of the nuclear physics, right? He is famous for his work on radioactivity and discovery of nucleus of an atom with the gold foil experiment. He got the Nobel Prize in Chemistry in 1908, right? Now, let us think of an activity in an open field to understand the implications of this experiment, right? Let a child stand in front of a wall with his eyes closed. Okay. Let him throw stones at the wall from a distance. So he will hear a sound when each stone strikes the wall. Okay. Now, if he repeats this 10 times, he will hear the sound 10 times. But if a blindfolded child were to throw stones at a barbed wire fence, ठीक है, most of the stones would not hit the fencing and no sound would be heard. ठीक है? This is because there are lots of gaps in the fence which allow the stone to pass through them. Okay? Following a similar reasoning, Rutherford concluded that the alpha particle scattering experiment, okay, इसे use करके क्या क्या conclusions आए हमारे पास? Most of the space inside the atom is empty क्योंकि most of the alpha particle pass through the gold foil without getting deflected. Straight चले गए तो काफी सारा space empty है. Very few particles were deflected from their path, which indicates that positive charge of the atom occupies very little space. ठीक है? And few alpha particles were deflected by 180 degree. मतलब ऐसे गए और ऐसे ही वापस आ गए. ठीक है? Indicating that all the positive charge and mass of the gold atom were concentrated in a very small volume within the atom. ठीक है? तो ये हमारे कुछ conclusions थे. Now, from the data, he also calculated that radius of the nucleus is about 10 to the power 5 times less than the radius of the atom. The nucleus बहुत ही छोटा है as compared to the atom. Okay. So he put forward the nuclear model of atom. ठीक है, features क्या क्या हैं इसके? There is a positively charged center in an atom which is called nucleus. Nearly all the mass of an atom resides in the nucleus. Then electrons revolve around the nucleus in circular paths, and size of nucleus is very small as compared to the size of the atom. Right? Very very important question. Rutherford's model में से mainly question आता ही है आपका exam, right? Then there were some drawbacks of the Rutherford's model of an atom. Let's see that. See, revolution of the electron in a circular orbit is not expected to be stable. ठीक है? Any particle in a circular orbit will undergo acceleration और उसकी वजह से it would charged particles will radiate energy. Okay. So revolving electron क्या करेगा? It will lose energy and finally fall into the nucleus. अगर ऐसा होता तो atom will be highly unstable or matter will not exist in the form that we know. ठीक है? But we know that atoms stable होते हैं. So this is the point which Rutherford's model was not able to explain, right? Next came the Bohr's model of atom, right? Now, in order to overcome the objections raised against Rutherford's model of an atom, Niels Bohr put forward the following postulates about the model of an atom. Okay, he said like only certain special orbits known as discrete orbits of electrons are allowed inside the atom, right? While revolving in discrete orbits, electrons do not radiate energy. This is what he said, right? Now, these orbits or shells are called energy levels. Energy levels of an atom are shown here. जैसे ये nucleus है, फर्स्ट एनर्जी लेवल n इक्वल टू 1, इसको k शेल बोलते हैं हम, n इक्वल टू 2 l शेल, n इक्वल टू 3 m, n इक्वल टू 4 n शेल. ठीक है, these are energy levels of an atom. Orbits or shells, they are represented by capital letters k, l, m, n or numbers 1, 2, 3, 4, right? And talking about Niels Bohr, he was there from 1885 to 1962. He was born in Copenhagen on 7 October 1885. He was appointed professor of physics at Copenhagen University in 1916. He got Nobel Prize for his work on the structure of atom in 1922. Okay. Among Professor Bohr's numerous writings, three appearing as books are Theory of Spectra and Atomic Constitution, Atomic Theory, and the Description of Nature, right? Now let's talk about neutrons. So in 1932, J. Chadwick discovered another subatomic particle which had no charge. Okay, mass iska tha nearly equal to that of a proton. So it was eventually named as neutron. Okay, neutrons are present in the nucleus of all atoms except hydrogen, right? In general, a neutron is represented by small n. Okay. Mass of atom हम किससे देंगे? Sum of the masses of protons and neutrons present in the nucleus. Right? So this completes the structure of atom. If any thing is not clear, you can post it in the comment section. And do subscribe the channel Learn with Nisha ji and stay tuned. Thanks for watching the video.